Let's find more about this as you come with us in our thrilling adventure at SKYRANCH Tagaytay.
Uniform circular motion, or UCM, has three motion characteristics. First, it is the motion of an object traveling at a constant speed on a circular path. Second, an object moving in a circle is accelerating due of the change in direction. Third, an object that is undergoing uniform circular motion is called the net force. This force can also be said as inward or centripetal force. If there is no net force on an object, it would still continue in a straight path. A person's weight changes when he or she is riding inside a gondola of a Ferris wheel, which involves physics. When gondola is at the highest point it can reach, the person's weight inside it becomes lighter than the weight when it is at the bottom because weight becomes heavier. A person's weight can only be felt when gondola is already aligned at the middle. To prove that there is really an involvement of physics, I and my groupmates rode on a said sky ice. When we are on the middle of riding it, nothing changes, but when we are already at the top of the Ferris wheel, we felt that our weight is lighter.
To analyze the Ferris wheel's physics, we must first simplify the problem. The figure shows a schematic of the Ferris wheel illustrating the essentials of the problem, where P1 is the topmost position and P2 is the bottommost position. Point P is where the gondolas are attached to the Ferris wheel. Point C is where the passengers sit. R is the radius of the Ferris wheel. W is the angular velocity of the Ferris wheel in radians. The force acting on the passengers are due to the combined effect of gravity and centripetal acceleration caused by the rotation of the Ferris wheel with angular velocity. The figure shows a free body diagram for the passengers at these locations, where mg is the force of gravity pulling down on the passengers, where m is the mass of the passengers and g is the acceleration due to gravity, which is 9.81 meters per second squared. N sub 1 is the force exerted on the passengers by the seats at point C at location P1. N sub 2 is the force exerted on the passengers by the seat at point C at location P2. A sub C is the centripetal acceleration of point P. This acceleration is always pointing towards the center of the wheel. So at location P1, this acceleration is pointing directly down, and at location P2, this acceleration is pointing directly up. Centripetal acceleration is given by A sub C equals W squared R. At these two positions, A sub C is a vector which is aligned parallel with gravity, so their contributions can be directly added together. By Newton's second law, summation of F equals mass times acceleration, where summation of F is the sum of the forces. To solve for the force exerted on the passengers at point C at location P1, we equate force exerted at location P1 minus mass times acceleration due to gravity is equal to mass times centripetal force pointing downward, and we will get an answer of force exerted at location P1 is equals to mass times acceleration due to gravity minus centripetal force. Next, to solve for the force exerted on the passengers at point C at location P2, we equate force exerted at location P2 minus mass times acceleration due to gravity equals to mass times centripetal force pointing upward, and we will get an answer of force exerted at location P2 equals to mass times acceleration due to gravity plus centripetal force. Here is our sample solution. We can see that n sub 2 is greater than n sub 1. This means the passenger feels the heaviest at the bottom of the Ferris wheel and the lightest at the top. So basically, the motion of a Ferris wheel affects your body's apparent weight, which varies depending on where you are on the ride. The riders only feel their true weight when the centripetal acceleration is pointing horizontally and has no vector component parallel with gravity, and as a result, it has no contribution in the vertical direction. This occurs when the riders are exactly halfway between the top and the bottom. Here are other examples that we saw in SKYRANCH that involves physics, like super biking that involves friction, drop tower that has free fall and uniform circular motion, and lastly, we saw an inflated playground that involves Newton's second law of motion.
Fast enough, you can fly away. You gotta make a decision. Leave tonight or let me die this way.